Welcome back to All This Math. This is Professor Parker, and for today's lesson, we're going to solve a system of linear inequalities. Linear inequalities. Linear because the biggest exponent you see is a 1, or the biggest exponent you don't see is a 1, because if you see an x, it don't got no exponent, that's x to the first power. All right? You got, let's see, negative 1/2 x, that's another x, that's x to the first power. So that's why these are linear. Also, when you draw the graphs of the boundary lines, they would be straight lines. They're not going to be curves. They're not going to be parabolas and none of that. They're going to be straight lines. All right. Now, the way you solve a system of linear inequalities, at least one way, the most popular way, is you graph the boundary lines of each of the inequalities. All right. And I'm going to show you what a boundary line is and all that, so don't worry. You graph the boundary lines and then you shade or draw either above it or below it, right? Wherever the boundary line is, you either shade above it or you shade below it, okay? So let's do this. First, you want to take the first linear inequality and rewrite it as an equation, So instead of y is greater than 4x plus 1, you want to rewrite it on your paper as y equals 4x plus 1. So you got y equals 4x plus 1, right? Now, the purpose of doing that is so you can graph the line. So in order to do this, you should know how to graph linear equations, right? If you know how to graph linear equations, then you can graph linear inequalities, all right? So the difference is the symbol right here. Equal sign, greater than, equal sign, greater than, equal sign, less than, equal sign, less than. That's the difference, all right? Now, you only need two pieces of information in order to draw the line. You need the y-intercept and you need the slope. That's why we call this slope-intercept form, because when you look right at it, you immediately can tell what the slope is and what the y-intercept is. This is the slope right here, this coefficient of x. This is the y-intercept right here, the number at the end. So first we start with the y-intercept though. So we call it lowercase b. So we say b equals 1, right? B equals 1. That's my y-intercept. That's like your address. That's like your house, right? That's where you start at. That's your starting point. All right. So it's the y value where the line is going to cross the y-axis. See right here, we got the y-axis, we got the x-axis. All right. So we're going to plot this point on the y-axis, a positive 1. All right, and shout out to Morgan State University. I decided to do, let's do blue and orange in honor of my alma mater down in Baltimore. All right, so I'm gonna do blue for this one. Matter of fact, let's make this one blue. And I'm gonna do orange for the second one right here. All right, so we got blue. The y-intercept is a 1, so I go on the y-axis and I find positive 1. The negative numbers are all down here, positive numbers is up here. So I do that. Plot that point right there. All right. Now, next thing I want to do is I want to identify my slope, and then I see how we're going to use the slope, right? I'm going to tell you how to use the slope. So we got m equals 4. Now, with a slope, you want the slope to be in a fraction form because the slope tells you how to move vertically as well as horizontally. Vertically, up and down, as well as horizontally. So we need to change this into a fraction, all right? So the way you change any whole number into a fraction is you just throw a 1 underneath of it. Just give it a denominator of 1, right? So the top number tells you how far to go up or down. Bottom number tells you how far to go left and right. This is a positive 4, so that means we're moving up 4 spaces. This is a positive 1, so that means we're moving to the right 1 space, right? So from here, from the y-intercept, right, that's why I start. Like I told you, the y-intercept is like your address. That's like home, right? The slope is not a point. That's a common mistake a lot of people make. The slope ain't a point. The slope is a set of directions or instructions as to how to get to the next point, or how to get to somebody's house, or how to get to the store. If somebody tell you, go up the block, go up 4 blocks, and then, bang a right, 1 block over, you're going to be there. That's what the slope means. That's all it is, for real. That's all it is. All right. So up from here, I go up 4. I go 1, 2, 3, 4. As long as I know how to count, I could do this, right? It ain't that deep. All right. It's just a lot of steps. It's a lot of steps, but if you practice and do enough problems, the steps are going to become secondary to you. You're going to develop what's called like a muscle memory. So don't even worry about it. So you go up 1, 2, 3, 4 over 1, draw your second point right there. All right. So now what I'm going to do is I'm going to draw a line through these 2 points. Some teachers want you to do at least 3 points. I'm not that teacher. I'm not him. You know what I'm saying? So I like 2 points. I'm good with 2 points. All right. But the question is, should my line be a dashed line or should it be a solid line? Should it be dashed or should it be solid? Because there's no equal sign here along with the inequality, it should be a dashed line, right? So watch what I do. I'm going to draw it like a solid line, right? Put the arrowheads on the ends. But then what I'm going to do is I'm going to just erase some of the ink. Let's get messy. So it'll look like a dash line. That's it. That's all I'm doing. All right, so now we got a dash line. Right, we got a dash line. And again, it should be a dash line because, make that dash too. Put a space in there too. It should be a dash line because we don't have an equal sign. All right, so this is the boundary line. This is the boundary line. Now, where would I shade at? Because it's an inequality. Let's go back to this. This is saying that y is greater than 4x plus 1. Now, this expression right here, 4x plus 1, this is like, that's like the line, right? This part right here represents the line, right? Y represents what we're going to shade at. So the part that we shade is greater than the line. So think to yourself, right? If it's greater than this line, where would I shade at? Don't this look like this would be like above the line? Because the line is slanted that way, right? So all this over here is considered above the line. So what I do is I just draw right here, right? It don't gotta be no work of art, you know what I'm saying? Just shade in over here, just like this. Now there's another way to figure out where to shade. It's called using test points, but I'm not gonna get into that right now. I think I got another video on the channel. Make sure you subscribe to the channel, by the way, where I go into using test points. All right, but this is good for now, especially because we're in slope-intercept form. If we was in standard form with the equation or the inequalities, then we'd have to use test points. But anyway, we good with this. So this is completely done. Now we got to do the same thing for this one. All right, so now let me rewrite this one. The second one, let me rewrite this one as an equation. So I can do my boundary line. So I got y equals negative 1/2 x minus 2. Now I need my y-intercept and my slope, just like I did up here. So my y-intercept is still the number at the end, -2 this time. It's not positive, it's a negative. Don't leave that negative sign out. A lot of students like to leave the negative sign out because -2 and 2 are not the same thing. So don't leave that negative sign out, right? Even when you say a problem out loud out your mouth, don't leave the word negative out. Say the word negative. All right, so we got b equals -2, and then m is still the coefficient of x. In this case, is -1/2. Now, here's the thing. This is already a fraction. But when you got a negative fraction, some people get confused because they don't really understand which number should be negative and which should be positive. So dig this, right? If you have a negative fraction, right? Like this whole fraction is negative. It's -1/2. That means that in reality, if you was to break it down, like between the numerator and denominator, that means that one of those numbers got to be negative. Not both of them, just one of them. Because if you make both of them negative, which a lot of people think you should do, which is wrong, don't do that. If you make both of them negative, what you end up doing is really creating a positive fraction, right? It shouldn't be a positive fraction. It's a negative fraction. Because think about it like this. A fraction is just a division problem. And you got to know the rules of arithmetic for positive and negative numbers. If you divide a negative by a positive, you always going to get a negative. So that's why if you got a negative fraction, that's the same thing as making one of these numbers negative or treating one of these numbers like they're negative and treating the other one like it's positive. So, and here's another question. Does it matter which one you make negative? No, it don't. It don't matter. What I usually do though, this is me. This is how I was taught. What I usually do, I usually just make, I go ahead, I just make the top number negative. I just make the top one negative and I make the bottom one positive. So the top is negative, the bottom is positive. It don't matter. It don't make a difference. What's going to happen is you're going to end up with the same line. You'll end up with a different point. Like if I switched it up, made the bottom one negative and the top one positive, I would end up with a different point after I leave -2, but it would be the same line though. You know what I'm saying? It would end up being the same line. So look, so I started -2, right? I need to graph that. Let me graph that though. Because why am I going to -2? Because that's my y-intercept. Remember that y-intercept is your house. That's your starting point. And I got a new line, right? So we finished with this line for now. Now we on to this line. We on to the next one. We on to this line. So my y-intercept is -2. So I go to the y-axis and I look for -2. I know this is 0, 0. So I go down to get to the negatives. -1, -2. Oh, wrong color. Right, we're doing Morgan State, blue and orange, right? Yeah, we already did the blue. Now we got to do the orange. So now we got -2. That's my y-intercept. Then I'm going to go down 1 and up 2 because that's a negative, right? So if that's a negative, that means I'm going down. That's positive. I'm going to the right. So I go down 1 and I go right 2. 1, 2. Right? So that's my 2 points. Y-intercept, use the slope to get to the next point. Again, the slope is not a point. The slope is not a point. I can't stress that enough. A lot of students make that mistake. They think the slope is a point. No, the slope is like, You know what I'm saying? Like, I don't know, like Google Maps or Waze app or whatever. It's the set of directions that tells you how to get to your destination, right? That's what the slope is. The slope is just a set of directions. This slope is telling you to go down 1 and go over 2. That's it. All right. So now you draw the line. I'm going to do this. So I got that. I got that. Arrowheads. But look, it's only less than. It's not equal to. So this should be a dash line. So I'm going to do this. I should use the eraser. My hands going to be all dirty. It's all good. I got soap and water. It's cool. All right, so look. Make it a dash line. Yeah, so this is a dash line too. It's a dash line also, right? So now, where do I shade at though? If this expression represents the line itself, and this is saying that y is less than this expression, we're saying that y is less than the line itself. So y is the shaded area. So that means I'm going to shade everything below. So think, less than, doesn't it make sense to shade below? If it's less than, you underneath of it, right? This is above it, right? So if it's saying y is greater than, we would shade up here. Now, we shade down here because y is less than this line. All right, so I just do this. Now, how do you know what the solution is? The solution to this system is the shaded area that has 2 colors on it, or the overlap. All right, so all of this over here, where you see the blue and the orange, right? This is the solution. So what does that mean? That means that I can pick any point from in this whole region, in this whole area. And think about it, it extends because the line goes on forever in that direction. This line goes on forever in that direction. So any part of this region that would be part of this, right? Underneath of this line and to the left or above this line right here, right, is a valid solution. It means I could pick any number in that region, right, or in that area, any X value and Y value, and plug them into both of these, and it'll be a solution to both of them. Not just one of them, not none of them, but both of them. If I pick something from over here, it's not gonna work for neither of them. If I pick something from over here, where it's just blue, it's only gonna work for this one and not this one. If I pick something from down here, it's only gonna work for this one, but not for this one. So you want the solution. The solution is a point any point, and it's gonna be an infinite number of solutions. With inequalities, a system of inequalities, you're gonna have an infinite number of solutions all the time, right? With systems of equations, it's gonna be a little different, right? Usually it's only one solution with a system of equations. Sometimes you could have an infinite number of solutions, but that's rare. Sometimes there ain't no solution. That's also kind of rare, right? At least in terms of the problems you're gonna see in the textbook. But anyway, the region right here is where the solution is. All right, so look what we did. Quick recap. You look at your system of inequalities, you make boundary lines. You find the boundary lines. You treat them like equations. Y equals 4x plus 1. Draw the boundary line. Use the y-intercept and then use the slope to get to the next point. You got 2 points, draw your line. Boom, it's a dash line. Why? Because it ain't equal to. It ain't equal to, so it's a dash line. All right, this one, do the same thing. Y-intercept is -2. Plot -2. Boom, use the slope. Get to the next point. Go down 1, go to the right 2. All it is instructions. When you see equations, an equation is just a set of instructions. That's all it is. It's like a recipe on a box if you try and bake a cake or whatever. That's all it is. All right? It's just a set of instructions. You go down 1, go over 2. Boom, your second point. Draw your line. All right? It's a dash line. Why? Because it's not equal to. Now, y is greater than all this, so you shade above that. All right? Since this is slanted to the right, we consider to the left being above. All right? Y is less than all this, right? So that's underneath of that. Shade all down. What's your solution to the whole system? The solution is where you see both colors at. All of this up in here, all up in here. That's the solution. And that's how you graph or solve systems of linear inequalities. All right, now I showed you how to do it. You could use this video as a guide, but the reality is if you want to get proficient, you really want to master this, you really want to know how to do it, you got to practice on your own. So what you should do is ask your professor, ask your teacher, ask whoever for more examples, for more practice, so you can go practice on your own and then master this all by yourself. All right, so you'll always know how to do it and you'll develop that mathematical muscle memory. All right, so I hope this helps. Go get some practice. I'll see you all in the next video. Peace.